All right, cool. So today we are going to transition from limits, which I know we worked on the past couple weeks, into something called a derivative. Now, let me make something very clear. A derivative, I will go into very specific details over the next couple of weeks about what a derivative is and how to use it. Today we have to practice sort of the derivation of what a derivative is. We have to derive a derivative. From a limit and practice that first. Then I'm going to give you a visual on it. So I kind of just want to apologize because I'm going to talk about let's find the derivative over and over and over, and you're not going to know exactly what that is. I will clarify that in the following weeks, okay? So first let's just practice whatever this is. This is going to be the first major definition or formula that you will have to know in calculus, and it will show up all year long. And it looks a little something like this. The limit as x approaches h of f of x plus h minus f of x all over h. And what you're supposed to do here, you know what, come back over here because I'm being silly. That's the wrong notation right there. Let's do, sorry guys, haha, I hope you're using a pencil. That was supposed to be h approaches 0. I just kind of got on autopilot and wrote it incorrectly. But anyways, this formula right here is, it is the limit definition of a derivative. So those two go together, and you're going to be asked to use this in multiple ways, and we're going to practice the heck out of it. Now it says, but first a refresher, and the refresher is because my students used to mess up the front part of the formula. So just as a refresher, remember that, you know, if I say that f of x is x squared minus 3x plus 1, okay? If I were to say f of 2, what would you do with the 2? Well, you would just plug it in, right? And then you would find a number, okay? Or if I was to say f of p, you would just take all the x's from above and replace them with a p. So this is just remembering function notation. Whatever goes in the parentheses is what you're evaluating your function at. So it replaces the x or x's that were there before. So when I write f of x plus h, it doesn't mean to recopy this and put a plus h at the back. That's not at all what it means. It means to replace every x with x plus h. So it would look something like this. So that's really important. There's actually going to be a lot of your friends that mess that up, or at least there always was in my calculus class. So hopefully you're not going to be one of them that messes it up. So you do need to actually substitute. So let's make up a few examples. So our goal on all of these, all three of these, the goal is going to be to find the derivative. Now, even though you don't know what a derivative is visually yet, we are going to find it using that definition from above. And I'm just going to make up a random polynomial. Let's let f of x be 3x squared. Let's do that, 3x squared. So if this is the problem at hand, then what we're going to do is that definition from above. So it says to take the limit as h approaches 0 of, okay, now what does that say? It says f of x plus h minus f of x over h. So I'm going to replace this and I'm going to replace this using the given formula, okay? Now it should be clear that since that's just an f of x, that you're just going to replace it with that 3x squared, okay? So that should be pretty easy. But the f of x plus h, remember what I said over there. X plus h has to replace your x. So it should look like this. 3 times x plus h squared minus 3x squared all over h. So I'm still keeping this limit thing in the front, but all of this simplifies into that. I hope that makes sense. Okay, rewatch something if it didn't make sense. Now from here you do need to simplify because what should happen in every single problem, what should happen is the h in the denominator should cancel. And that's important because if you tried to plug in a 0 right now for h, you would have blah, blah, blah. You'd have a bunch of mess up here. But in the bottom, you would just have a 0. And you can't have a 0 in the denominator. It'll either be undeterminable or it will be a does not exist. So we need to get rid of the h in the denominator. And so to do that, you just do algebra. So I'm going to FOIL this. So that'll be x squared plus xh, no, two of them, plus 2xh plus h squared minus 3x squared all over h. Now I would distribute my 3 to everybody. Okay, so that's going to be 3x squared plus 6xh plus 3h squared minus 3x squared all over h, okay? And when that happens, look at all the stuff that's about to cancel, guys. I've got a positive 3x squared here and a negative 3x squared there. And I guess that is the only thing that cancels. But what's cool is that everything left behind has an h in it. And if everything left behind has an h in it, why not factor and cancel out of h from everybody? So in other words, if I take an h out of itself down here, it's just a 1. I'll take the h out of that, and I'll take one of the h's out of this. So it's now just a 3h, okay? Now what do we do with this answer? Because right now we're staring at a 6x plus a 3h. Well, remember, it's behind this. Limit as h approaches 0. It's behind this. So now you can analyze your limit. So plug in a 0 for h. That'll go away. You'll be left with 6x. So 6x is the derivative of 3x squared. And we will talk about that relationship and what this actually is on a graph next week. Okay, but let's keep plugging away and practicing this formula. I'll go a little bit faster on these. Okay, what if it was a radical? So same goal as over here, but now f of x is, let's say it's 2 times the square root of x. Okay, so if this was our problem, then what we would need to do is the same thing. We're going to do the limit as x approaches 0 of, okay, now in the front it's f of x plus h. So I need to replace what's under the radical with an x plus h, okay, minus the original f of x all over h. And I'm supposed to algebra my way out of this, and hopefully one of these will cancel. Well, guys, you can't do much with that. I can't distribute that. That is not legal. So if you were already thinking about distributing, get that out of your head. Not legal to distribute into a radical. So when this happens and you're like, well, I can't do anything and I can't cancel my h, you feel like you're done, but you're not. If you remember a video a week or so back, there was this thing called a conjugate, and it's a nice trick to help clear things up. So I'm going to multiply both the top and the bottom by the conjugate of this radical. And the purpose of doing that is that a lot of times it does help everything clear up. So remember the conjugates where you just change the sign in the middle. So it's now a plus. And what I'm going to do is I'm going to multiply top times top. And instead of multiplying out the entire denominator, I'm just going to recopy the denominator, because it'll be simpler to cancel that h if you leave it in factored form, okay? So this is going to be the limit as x approaches, as h approaches 0. And when I factor out the top, or FOIL, that's going to be, we got all this foiling to do. When I multiply the first times the first, it'll be a 4 times x plus h, okay? Then what's going to happen is I'm going to have a positive one of these, but then a negative one of these. So those are going to cancel, so I don't even need to write it. And then the last term will be a minus 4x. And it's going to be all of that over h times all that mess. Cool. So I just recopied my denominators. I actually FOILed out the top. And now you might already see it, but look what's happening on top. That's a 4x plus 4h minus 4x. Well, the 4x's are going to cancel. So you're just going to have a 4h on top. And on the bottom, h times all this madness. And where do you think I go from here? Well, we get to cancel the h. Do you see it? There's an h up here, there's an h down there, cancel, cancel. So I'm supposed to find the limit as h approaches 0 of 4 over 2 times blah, 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 plus blah, blah. Okay, so now I can actually plug in my 0 for h. So the minute you get that h to cancel, try plugging in that 0 and see what happens. And I'm going to plug in a 0, and I'm going to have a 2 root x plus a 2 root x. Isn't that just a 4 root x? Yep, it sure is. And then my 4's are going to reduce. So my answer is just 1 over the square root of x. And I would just leave it like that. I mean, you could write it as root x over x if you want, but I think that's a fine answer. So that is the answer. That's the derivative of that. So how do you know if you've done it right? Well, you've done it right if you got your h on the bottom to cancel, and then if you were able to plug in stuff, and your answer should not have an h in it, like anywhere, right? Because you're plugging in a 0 for it. So you should have an answer of just x's or numbers or something like that with no h's, okay? All right, cool. So what about with rational functions? Okay, a rational function is just a fraction, right? So in this case, we're going to start with, well, what if our original f of x is, let's say, 3 over x, and we are asked, we're going to keep it easy for now, okay? We are asked to find the derivative. So we're going to plug into this and see what happens. I keep doing that. H. It's not an x, it's an h. Okay. So I need to first take my f of x and figure out f of x plus h. So it would look like that. I'm just substituting x plus h in the place of my denominator. And then I'm going to leave that the same because it's the original f of x back here all over h. Now these look easier. And in fact, I think they are easier than radicals because all you have to do is simplify. You need to come up here in your numerator and you need to get a common denominator and put those together. And then you need to just sort of put this whole fraction together and see what happens. So in this numerator, it looks like the common denominator up here is going to be x times x plus h, which means that this numerator I need to multiply by an x minus this numerator I need to multiply by the x plus h. And it's all over h, okay? Now what? Now I'm looking up here, I'm going to simplify what I can, so I'm noticing a little distributing there. Now if I distribute this, it's going to be 3x minus 3x, and so that's gone, and then a minus 3h over x times x plus h over h. So this is my new problem. I still can't plug in the 0 for h because I haven't canceled anything yet. But remember, if you've got a fraction, a 3-part fraction, this just ends up being like h over 1, and you can flip and multiply. So it's going to be this, right? H over 1 turns into times 1 over h. Now look, your h's cancel. Cancel, cancel. Yay! And so the answer is negative 3 over x times x plus h. Now do the limit as h approaches 0, and you will get negative 3 over, what will that be, x squared? Yeah, x squared, because that's a 0, and then you'll just do x times x. Okay, cool. So that is a lot of what you'll have to do with these. And I have a box out over here that says working backwards. And the purpose for that is because on a test in class, or on the AP test at the end of the year, the AP test and or your teacher, we like to ask a question backwards. And in other words, you might see something like, this is kind of silly, but you might be told, hey, it won't say hey, it'll say like the derivative of f of x is, and it'll give you like this madness. Okay, so maybe it's a problem like that, and I hope you can read my writing. The sine of 2 times x plus h minus the sine of 2x over h. And it's going to say, hey, the derivative of f is blah, 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 and then it's going to be like, what is f? So you don't necessarily have to do any kind of simplification or trying to get stuff to cancel, or you're not finishing it out like we did any of these other ones. All you're doing is recognizing this formula and going, oh, hey, if I've memorized this formula and all they want is f of x, then where do you look? Well, where you should look should be at the back, right? Because this spot is supposed to be f of x plus h, and this spot back here is supposed to be f of x. So you would say sine of 2x. Done. So that's the working backwards that I'm talking about there. Okay, good luck on your homework. It's lots of algebra. It's just a heavy algebra unit. Not a lot of practice problems though. And then like I said, the next 2 weeks, these last 2 weeks of summer are all about derivatives, and you're going to get such a good understanding, I hope, of what they are, and a big heads up on all your friends. So we'll see you in the solutions video.